Hello everyone, welcome to day one of partial fraction decomposition. We're going to learn two different techniques to do, or two different methods to do this technique. And then the next video will be the next two methods, and then we'll put it all together. You definitely need this in order to be able to move on to calculus next year. So first of all, let's just start by adding these two rational expressions together. So hopefully you remember that when you're adding two rational expressions together, what you are doing is getting common denominators and then combining the numerators. So the common denominator is x plus 3 times x minus 4. My 2 needs to get multiplied by x minus 4, and my 3 needs to get multiplied by x plus 3. Normal common denominator stuff. When I simplify this out, I get x squared minus x minus 12 in my denominator. And my numerator, let's see, this is 2x minus 8, and this is 3x plus 9. Looks like I get 5x minus 1. Oh, how about plus 1? Good thing I had the answer down there. So here is my solution. And what we are learning to do today then is to start with this and break it down or decompose it back to where it like it kind of looked like it began. So going backwards, so taking this and going backwards to this. Okay, so there's basically what I just told you. It's the process of starting with the simplified answer and then taking it back apart, so you're decomposing it. So here's the two different forms that we're going to be talking about today. We've got the form that's called the non-repeated linear factor form, and then the repeated linear factors. So here's some examples of each. On the left-hand side, the denominators are all linear, and none of them are like multiplicities bigger than 1. So nothing is squared, nothing is cubed. It's just first degree, first degree, first degree, first degree, first degree. Also notice that the numerators are all 1 degree, at least 1 degree less. They have to be a degree less. They could be numerous degrees less, but they have to be 1 degree less in order for this process to work. And then in the right-hand column, you'll see that you have linear factors. X plus 1 is a linear factor. X plus 2 is a linear factor. But then it's repeated. So this is the same as if I were to write x plus 1 times x plus 1. Which is why we call it a repeated linear factor. Okay, so I'm going to show you the steps to take to do these and then do the actual problems with you. So here's for our non-repeated linear factors. This is the most basic of them. 5 steps. The first step would be to factor the denominator if necessary. Sometimes it will be already factored for you. The second step, which is hard to read here, says create partial fractions using variables to represent the constants in the numerators. Using variables to represent the constants in the numerators. Step 3, set up a system of equations to solve. And then you can also use matrices on your TI, and I'll remind you how to do that as well. And then number 4, solve the system, whether it's on the TI or by hand. And then number 5, make sure you actually rewrite the problem. So when you go backwards, you want to make sure you write it as the 2 or 3 or 4 separate fractions. Okay, hopefully this problem looks familiar. Here's the problem we started off with. We're going to follow those 5 steps. So the first step, again, was to factor the denominator. So that becomes 5x plus 1 in the numerator, denominator x plus 3 times x minus 4. Then we are going to rewrite this as, this is the step, I'll show you, I'll go back. This is the step 2. It says create partial fractions. So what this means is you're creating however many fractions you need depending on how many terms you have in the denominator. So one of my fractions would be x plus 3, and my second fraction would be x minus 4, or switched, it doesn't matter. And I'm going to put variables in the numerator that I'm going to be solving for. I'm going to call them a and b. Call them whatever you want. I would avoid using x, but you could use whatever variable you'd like. Now it's like I'm going to cross multiply kind of to get rid of this. I'm going to like multiply my denominator through. So if you want to think of it like this, I guess it's not really cross multiplying. We're multiplying by x squared minus x minus 12, which when I multiply by that, the denominator in the first fraction goes away. So I'm left with 5x plus 1. And the x plus 3 gets canceled, and my a is going to get multiplied by x minus 4. And in the second fraction, the x minus 4 goes away, and the b then gets multiplied by x plus 3. And then this simplifies into 5x plus 1 equals ax minus 4a plus bx plus 3b. Okay, so here's where you need to then have an understanding of how equations work. I have some stuff on the left and I have some stuff on the right, and we're saying they're equal. So what that means is if I have this 5x on the left-hand side, we're saying, hey, whatever happens on the right, those x's must add up to 5 so that they can stay equal. So this 5x term would be equivalent to if I combined these two x terms together on the right. So I'd be able to pull that stuff out and say, well, 5 has to equal a plus b. Okay. And then I also have this constant over here. So I have this 1 on the left-hand side. And then I have these two things here, the negative 4a. Well, look at there. Probably all sitting there going, Mrs. Casey, Mrs. Casey. B. So I have this negative 4a and this positive 3b that are constants on the right-hand side. I had distributed that incorrectly. So now I can say, well, 1 is the constant on the left, and that has to equal the combination of the constants on the right. So I've now set up a system of equations. This one is pretty easy to solve because it's 2 variables and 2 equations. It's not that difficult to work with. So I'm going to just do it by normal algebra by hand, right? So algebra 2, you learned how to do this. Even algebra 1, I think you learned how to do this. I'm going to multiply this top equation by 4, and that's going to help me to get rid of my a's. So I get 21 equals 7b, which means b equals 3. And then I just take that 3 and I substitute it for b up here. And so I have 5 equals a plus 3, which must mean that a equals 2. And then I rewrite the whole problem so that I have, let's make sure I have these in the right spots, 2 over x plus 3 plus 3 over x minus 4. So that would be the final answer that we're looking for. That would be your step 5, rewriting it. Up here at this spot right here, where we did the system of equations, you could also solve this with a matrix, which again, with this particular problem, I don't know if it would be that beneficial, but I want to remind you how to do it. That way, when we do harder ones, you can. So this would be a matrix where we're going to do what's called reduced row echelon form, or RREF, on our calculator. This is definitely a calculator question. So this problem, we're going to need a 2 by 3 matrix. Okay, the first row will be this first equation, and the second row will be the second equation. But remember, this is like your answer column. So this will be my A's, my A value column, my B value column, and my answer column. And then this will be equation number 1 and equation number 2. So this is going to have to be flipped because of the way this is written over here. And I'm going to use coefficients. So the coefficient on A for the first equation is 1, and the coefficient on B for the first equation is 1, and the answer for that equation is 5. The coefficient on A in the second equation is -4. On B in the second equation is 3, and the answer in the second equation is 1. And then this is going to go in your calculator and you're going to solve. So I'm going to open the calculator to show you how you do that. So to do this on your calculator, you go to second matrix. Matrix is this x to the -1 button. So second matrix, and you're first going to want to edit a matrix. You might have nothing in these spots, which means you're going to have to create that. So you go over to edit, you hit enter on whichever one you want to edit. I already have a 2x3 here, so I'm going to go ahead and edit that one. If you didn't have a 2x3, then you would change these numbers. So you'd hit whatever number you needed, if you needed a 3x4 or 4x5, whatever. And you just keep entering the numbers. So 1, 1, 5. This is already set up, as you can tell, because I already did this. Okay, so I've got the whole thing entered. So I'm going to exit out of that. So second quit. And now I want to do that RREF to this matrix. Okay, so I go back into the matrix, so second matrix, and now I want to do math. So I go over to math, and I want RREF, which is nearly at the bottom, so I'm actually going to arrow up, and it is B. And I want the matrix I just edited. So back into the matrix we go, and I want matrix A. So under names, I pick A. So here is our solution. This means, so remember, this first column we said was A, and the second column was B. So when A is 1 and B is 0, so when A, we have just A, it's equal to 3. And when B is 1, so when we have what we're looking for the B value, it's 2. So A is 3, B is 2. All right, let's do another one. So this one, I'm going to actually set it up like this so I can have my matrix set up correctly. So this factors into, let's see, x minus 3 and x plus 2. Okay. So then I get an x minus 3 here and an x plus 2 here, and then I pick some variables for my numerator, like a and b. And then I multiply the whole entire thing by the denominator so I can clear the fraction out. So when I do that, a gets multiplied by x plus 2, b gets multiplied by x minus 3, and the whole thing is equal to 6 plus 2. Now I just distribute. Okay, so here we are. And now I'm going to do the same thing I did before. So I'm going to go, well, this is an x term, this is an x term, and on the right side, that's my x term. So I get a plus b equals 6. And then I have, this is a constant, and this is a constant, and the right side, this constant of 2. So now I have 2a minus 3b equals 2. And then I want to, I'm just going to do this one by hand because I do feel like these are easier by hand. I'm going to multiply this by 3. I get 3a plus 3b equals 18. Combine them. I get 5a equals 20, so a equals 4. And if a equals 4, I put that back here. That gives me b equal to 2. And then we can't forget to write this as one fraction. So it's 4 over x minus 3 plus 2 over x plus 2. So that's my decomposed form. Okay, now we're going to go on to the second type of situation that we have. So this is what we call repeated linear factors. The steps are similar. So the first step is still to factor the denominator if necessary. The second step now says to create partial fractions, one for each linear factor and each repetition of the factors, to represent the constants in the numerators. Okay, so the only thing that's changing is we're going to have extra fractions that are related to the repeated factors. Third step is the same. Set up a system of equations and solve. You're more likely to use matrices on this one. Of course, then step 4 is to solve. And step 5 is to rewrite. And again, don't forget this as the most commonly missed part of the problem, is you don't finish it. Okay, so here's the problem we're going to start with. You can see it has this repeated linear factor. X is the linear factor, and it's repeated. Okay. Oh, let me actually do it on a different screen then, since it's not on the next slide. So hold on. There we go. Okay. I'm going to write it backwards again so I can have everything set up. So I have to actually have 3 fractions in this one. X plus 2 is going to just be on its own, no big deal. I'm going to call it C. It doesn't matter, but since I'm going left to right, I'm going to use that as C. Again, X is a linear factor. It's like it's written like this, X, and then to the second power. So I'm going to have X by itself in the denominator of this first fraction, and then I'm going to have X squared in the denominator of the second one. But nothing changes about how I handle the numerator. It still stays a constant. Basically what we're saying is, well, to get X squared in the denominator here, I maybe could have had this to the first power here and to the second power here. We don't know if we had both of them or just this one here, the B one. Okay, so we have to check both to see if they exist. All right, now we multiply through by the whole entire common denominator, and this is where it can get a little tricky. So this stuff is gone over here, and my first fraction, when I multiply by the common denominator, I have an X that needs to get multiplied to it, as well as an X plus 2. And for the B, I don't need any X's because I've got both of the squared ones, but I do need an X plus 2. And then for the C, I don't need the X plus 2 that's down here. That gets canceled out. I just need these X squares. So really it's like doing a common denominator, right? I'm just not keeping the denominator there. Okay, I need to go ahead and distribute. I now have ax squared plus 2ax plus bx plus 2b plus cx squared equals 5x squared plus 3x minus 2. Now I'm doing the same thing as before. So I'm looking for those like terms on the left and the like terms on the right. You're welcome to regroup everything if you want to. So if you want to go and regroup all of the x squared terms, all of the linear terms, and all of the constants, you can do that. But I'm just going to do this. I see an ax squared and a cx squared on the left. And that means it has to equal the 5x squared on the right, so 5. Then I see this x term and this x term, and then an x term on the right. So 2a plus b equals 3 will be my second equation. And then my third equation, what color do I want here, is just this constant stuff. And so this one happens to be 2b equals negative 2. This one still isn't terrible to solve by hand because I can get b by itself here, and then I can substitute that answer into this b to solve for a, substitute the a answer in to solve for c, which I'll do that in a minute. But I also want to show you how this works on the calculator or with matrices here. So this would now be a 3 by 4 matrix, 3 rows, 4 columns. The first column would be the A, the second would be the B, the third would be the C, and the fourth would be the answers. And then we go by row, right? So the first row has 1 for the A coefficient, there's no B, 1 coefficient on the C, and the answer is 5. And the second equation has a 2 for the A, a 1 for the B, no C, and a 3 for the answer. And the last row has no A, 2 for the B, no C, -2. And you could put this in your matrix and go right in and solve it again in that reduced row echelon form. And I can't remember if that's the one I have in the calculator right now, so let's see. So notice that I have a 3x4 already set up, and I want to see if those are the same numbers I had. They are. Okay, so I put 1015, 2103, 020, -2. And once you enter all of those numbers in your matrix, so again, remember you get there by doing second matrix, and then we go over to edit, and you edit either the same one and change it to 3x4, or I always have one in there that's a 3x4. Then I want to do RREF, so go over to math, go up to B, then I'm going to go back into the matrix. I'm going to use the matrix B that I created, and then these should be our answers. So I get A is 2, B is -1, C is 3. So I'm going to snip that and put it on our screen. So A is 2, B is 1. So I have 2 over x. Sorry, B is -1. And then C was 3, which was x plus 2. Okay, and this is your final answer. All right, I'll do the next one without using the matrix. So same situation here. This one looks really similar, except for it hasn't been factored yet. So I'm going to start by factoring my denominator. It will factor into x squared times x plus 4. So this is actually a really similar problem. They won't all look like this, don't forget. So I'm going to have a over x, b over x squared, c over x plus 4. I'm going to multiply by the denominator, and I get 5x squared plus 3x plus 12 equals ax times x plus 4 plus b times x plus 4 plus cx squared. Distribute, I get ax squared plus 4ax plus bx plus 4b plus cx squared. Some of you might be able to skip this step once you start practicing, because you can obviously distribute like all in one step. So you're absolutely welcome to do that. Okay, so now I've got everything all separated out, and I'm going to find my values that go together. So I have a 5x squared and an ax squared and a cx squared. So I get 5 equals, don't know why I put that so far over there, 5 equals a plus c. I have a 3 for the x and a 4a and a b. And I have a 12 and a 4b. So like I said, I'm going to do this one by hand now. So since I have this 4b here, I divide by 4 and I get b equals 3. Then I'm going to put that 3 in here. So I get 3 equals 4a plus 3. So I actually get a equals 0, which means when I substitute that up here, I get c equals 5. Okay, so for this problem, that means I had no x 1 over x term. I didn't have anything for just the x in the denominator. So I end up with 3 over x squared plus 5 over x plus 4. So this problem did not have anything in that for that first fraction. All right. Hope you took good notes, and make sure you write down any questions you might have and ask your teacher or put those questions in the question and answer document.